So we left off after doing this portion of the problem. It says the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x. So if it says it's proportional, that means it's a direct variation, and we can assume this goes through the origin. So if it goes through the origin, then my equation that I'm supposed to write is just going to be y equals mx with no b value because the b value is 0. And the m value has the y on top. So the y value here was the weight on Titan. And its weight on Titan was 15 pounds. So we put 15 on top. The x value was its weight on Earth, which is 105 pounds. Who remembers what that reduced to yesterday? Xander?
1/7.
1/7. So if we know our slope is 1/7, our equation is going to be y equals 1/7 x. Get points taken off if you put 7x instead of 1/7. Make sure you put the y value on top, not the biggest value on top, the y value, whatever that one is. Maybe it's smaller, like it is here. How much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, I have this equation, y equals 1/7 x, that we said, which says that everything on Titan weighs 1/7 of what it weighs on Earth, because x is its weight on Earth times it by 1/7, and you get its weight on Titan. So y is always going to be smaller. Well, unless you're plugging in 0, it would be the same. So I'm going to take 3.5, which is what it weighs on Titan. And since the weight on Titan is the y value, we're just going to plug 3.5 right in for y, right there. So 3.5 equals 1/7 x. Have to get x by itself. How do I do that? Lizzie? Divide by 1/7. And that is the same as doing what? Yes, which would be easier to type into your calculator, wouldn't it? Right. So what do you get, Lizzie, when you take 3.5 and you times it by 7? 24.5, and we're a story problem, so we're talking about pounds. If you want to be specific, you can say pounds on Earth, but pounds would do. So something that weighs 3.5 pounds on Titan would actually weigh 24.5 pounds on Earth. Questions about how we did that? Okay, we're going to do it again here. This time we're talking about a factory worker and how much money they make. The daily wage y in dollars of a factory worker is proportional, which means it's a direct variation. It's going through the origin to the number of parts x. Okay, so we got x is the parts. I'm going to circle it this time. This might make it easier to remember. X is the parts and y is the dollars. A worker who assembles 250 parts in a day earns $75. Write an equation that represents this situation. Well, since it's a direct variation, we know it's going to look like this. Deegan? Yep. So in order to find the slope, all I have to do is divide the y by the x. I don't have to do y2 minus y1 over x2 minus x1 because this direct variation goes through the origin. That'd be a waste of time if I asked you to subtract 0 from both of them. Right? So I just need to write whatever the y value is over the x value. The y value is the dollars. So what number goes on top of our fraction? Christian? 75. The x value is the parts, 250. So you make $75 for constructing 250 parts, assembling 250 parts. What is that going to give us as a decimal? I'm okay if you write it as a decimal, as long as it's one that we can actually write in big ideas. What's that give you, Lizzie? 0.3. Does it repeat? Just okay, perfect. We can write that then. So our equation then is just going to be y equals 0.3 x. If you wrote it as a fraction, what would it say? Yeah, go ahead. Just write 3/10. That's right. Yeah, I would accept 0.3 like Lizzie said, or 3/10 like Carson said. Right. You can write either one of those. How much does a worker earn who assembles 300 parts in a day? So now that we have our equation, I'm going to plug 300 in for either x or y. That's the question. Is it x or is it y? Which variable is the parts variable? Jacoby? X is the parts variable. You're right. It says right up here. Okay. So we're going to plug 300 in right there. So Y equals 0.3 times 300. What do you get, Sky? 9? 90. Okay. And what did Y stand for? What was the Y variable? I think you circled at the top of your problem.
Oh, in dollars.
In dollars. Perfect. So I'm going to label out the dollar sign. Yep. Questions on how we did that? Once you have your direct variation equation, you can plug in for X or plug in for Y to find that missing value. So if I know that I make 3 or 0.3, basically 30 cents for every part that I put together, 300 parts is going to pay me $90 though. Which isn't much to get paid in a day. So I hope that he has some other income. All right, the distance Y in meters that a 4-person ski lift travels in X seconds. Okay, so I'm going to highlight again. Y distance meters. X seconds. The distance Y that a 4-person ski lift travels in X seconds is represented by the equation Y equals 2.5X. The graph shows the distance that a 2-person ski lift travels. Which ski lift is faster? Well, the speed, another name for speed is rate. And another name for rate is what? Lizzie? The slope. Exactly. So what we're really asking you to do here is just compare the two slopes. Now for the 4-person ski lift, they've already given us our M value of 2.5. That means that for the 4-person ski lift, it's traveling 2.5 meters, because it's Y first, per second, because it's X last, X on bottom. What's the 2-person ski lift traveling? I need to check this graph out. Let me ask you this. Is it a direct variation? It's proportional, goes to the origin. So I don't actually have to count rise and run. I can just divide. Xander, what are you getting when you divide?
2 meters per second.
Exactly. Take your Y, put it on top. Take your X, put it on bottom. If it travels 4 meters in 2 seconds, then it absolutely it's going to travel 2 meters in 1 second. So the 2-person ski lift, I'll try to color coordinate this, is 2 meters per second. And so the red one, or the 4-person, is faster. It says graph the equation of the 4-person lift. Okay. This one, yeah, but it wants me to put it next to it. I'm just going to graph it next to it. The 4-person ski lift also goes through the origin, has a slope of 2.5. I don't know if I'm going to be really good at graphing rise 2.5, run 1 on a, I mean, like 2.5 would be like somewhere in this area, but I'm not completely sure. So instead of thinking of it as 2.5, what's another way I could think of it? Carson? Yeah, you could, yeah, exactly. You could think of it instead of 2.5, you could think of it as 5/2. That's right. So you could rise 5. Even then, though, I'm not completely 100% sure that that's 5. So if 2.5 is the same as 5/2, that means it's the same as 10/4. And the only reason I'm doing that is because I can definitely count up 10 and count up 4 and make sure it's at a nice spot on the graph. And it's going to go to the origin and it's going to look like that. And if you compare the two lines, you can see that the ski lift that's faster has a steeper slope. Oh, Y equals 2.5X. Duh, that's the equation.
They already gave us that. Beginning of the question.
True. But if you didn't realize they gave it to you, then you weren't going to be able to graph it. The table shows the distance Y in meters that a T-bar ski lift, now don't ask me what that is because I don't know, travels in X seconds. Compare its speed to the others. Okay, so for the T-bar lift, does it go through the origin? Doesn't look like they gave me that information. How could I tell if it goes to the origin? I wonder if we can find one similar to it up here. How could we tell that this was going to be a direct variation? Do you remember what we did, Jimmy?
Because you can tell if it's proportional.
Yeah,
by
exactly.
finding the pattern.
Tell if it's proportional by dividing and seeing if that pattern is the same. If you divide y by x and you get the same number, not only does that tell you it's a direct variation, it'll also tell you what the slope is. So let's do that for the t-bar. What's 2.25 divided by 1? You could just say it. 2.25. What's 4.5 divided by 2? Was it? Is it 2.5? It is 2.25. Okay, double checking on that. Okay. 6.75 divided by 3. 2.25. I'm going to get 2.25 the whole time. So not only do I know that this is going to go through the origin without it actually giving me the origin as one of the points, but I also know now what that constant pattern or that constant rate of proportionality is. My slope is going to be that number I keep getting. So its equation, since I know it goes to the origin, is going to be y equals 2.25 x, and that's it. No y-intercept because it's 0. And if I were to graph it, this will get real splitting hairs here, right? 2.25 we know is the same as 2 1/4, and 2 1/4 is the same as 9/4. I'm going to have to work with that. 9/4 would be somewhere here. And so it's going to be a speed between the other two. Obviously, you've got the red one being the fastest at 2.5 meters per second. Then you got 2 1/4 meters per second. And then the blue one was just 2 meters per second. Person?
The T-bar ski lift, it's kind of like, it's just shaped like a T and you're supposed to sit on it and it's terrifying.
How many people can sit on it?
One.
Just one? Okay.
Yeah, I've been on one before, like you're supposed to it's scary.
You think it would be reversed. Wouldn't the 4-person ski lift be the slowest one? Since you have 4 people have to board and 4 people have to get off?
But yeah,
No?
but
Okay.
that's more weight.
I mean,
so-
I've been snowboarding before. I know how difficult it is to get off, even with skis or whatever, of a ski lift. You would think the 4-person one with 4 people getting off of it would have to be traveling slower, but
There's more weight, so it has
Yeah,
to
'cause
travel
usually-
faster in order.
usually
to-
otherwise
Yeah.
it gets bogged down. Okay,
Ski lift's going downhill, so usually more weight on it would be pulling it down faster.
fair enough. Okay, we're almost done. Find the unit rate of each proportional relationship. To find the unit rate, since I know it goes to the origin, I don't have to count rise over run. I can just divide. What's 60 divided by 4? 15. That was, maybe I should have just done this one. What's 15 divided by 1? 15. So the unit rate is 15. What's the Y value labeled in? $15 earnings per hour, $15 per hour.
Hey,
Remember, unit rates have to have 2 labels. So if your graph goes through the origin, all the points on it are proportional, and we can just divide them the same way that we divided this here to find out what our unit rate was. This unit rate, 2.25, was 2.25 meters per second. I just didn't write it. Okay, the equation then would be y equals 15x. What about the hot air balloon? What's its unit rate? Same people. Lucy. Yeah, 5. 30 divided by 6 or 5 divided by 1. It's going to be 5. So label it for me, Lucy. 5 what? Feet per second. Yep. So remember the Y, since the Y always goes on top, we always put the Y label first then. Feet per second. And so what's its equation going to be? Christian?
y equals 5x.
That's right. Yep. All the lines are going through the origin, so I don't need a y-intercept value. The last one we're going to do, I'm going to skip that very last problem. We're just going to end here because I think there's one like this in the homework. The graph of a proportional relationship passes through the points 12, 16, and 1y. Well, the fact that it goes through a proportional relationship tells me it goes through the origin. May or may not be helpful for this problem though. But the fact that it says it's a proportional relationship is extremely helpful, because if it's a proportional relationship, then the x value of the first point to the x value of the second point is going to be proportional to the y value of the first point and the y value of the second point. And then because it's proportional, and we just did a homework on using cross products, I could use cross products to solve this. You should get an equation that says what? Shane? Excellent. And then y is going to be equal to? Yes. 3/4. No,
Yeah, it would be 4/3.
I think you divided it wrong. You would be dividing by 12, right? So it'd be 16 divided by 12. Wouldn't that reduce to 4/3? Be 4/3. What's that as a decimal? Do you remember, Owen? Yes, 1.3 repeating, which if I was writing that big ideas, it wouldn't let me put the repeating bars. I would have to put 4/3. I think that's why I put this one in here.
Or you could put 1 and 2/3. That's
1 and 1/3.
1 to 10.
Typically, we don't write slope or, well, never mind, this is the point.
Say that's a whole third more. They're really not.
All right, we'll stop there. So at this point, you have the period to either one, work on the 4.3 from yesterday and get that big ideas homework done, because it's due tomorrow. Or if you already have that done, tonight's homework is, apparently it has a number, K.16. On my computer, it didn't put a number next to it. It just said, literally said K point checkpoint, which is weird because they usually all have numbers, but K.16, and you're going to take it to 100. It's going to ask you a variety of questions like the ones from this homework, and I'm willing to help you. You have almost the entire second half. You got 23 minutes to see what you can get done on that. You need to finish yours. Okay, come on up and I'll give it to you. Seth? Yes.